record. Okay, now let's welcome back. So let's finalize the case of decision trees, especially in terms of deciding which is the node that we are going to choose out of the many uh, attributes or characteristics of our data. So we have seen that the information gain is one part, one criteria for us to choose which attribute we are going to use for a node, the node with the highest information gain. So now we have seen this table. Let's go to another example. So this is the playing tennis example. As we mentioned, normally we jokingly say this is like a British kind of person, or maybe some people who who are very particular about when to play tennis or not. Okay, so based on these attributes, this is the table that is taken, I think, 41 days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, 11, 12, 13, 14. Sorry, it's 14 days. For 14 days, this guy was recording and trying, or maybe not exactly 14 days, but for many days, and just trying to see which ones have unique output. Then he used that to do the training for his decision tree on whether it would help him to decide whether to play tennis or not on that particular day. So we have 4 attributes. So outlook, temperature, humidity, and wind. And the output is play. Yeah, yes or no. Okay. So let's just do immediately. Let me share. Let's solve this one immediately. So that is your data set. And now let's solve the information gain. So information gain, as we know, is absolute entropy minus the relative entropy. So information gain of, for example, X outlook is equal to the entropy, absolute entropy of the output, okay, minus the relative entropy of the output given the attribute X outlook. Okay, so that means that we are going to go through all the information gain for the outlook, for the temperature, for humidity, and for wind, and see which one has the highest information gain. And then we choose that as our first node. You understand? Okay, now, of course, the way to do is first solve for this. Maybe I'll choose a different color because to first solve the absolute entropy, okay, for the output. Okay, so now let's consider absolute entropy for the output. Here we go. So this one only. It's not relative to anything. So that information only of the output. So yes, how many yeses? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 yeses over 14. Okay, you have 14 entries. So that's it. 9 over 14 log 2 of 9 over 14 plus, okay, we know this. Okay, that one that is not yes, it should be no. So 14 minus 9 is 5. So 5 over 14 log 2 of. So this is the yes part, and this is the no part. Okay. So the total absolute entropy for this is minus 94. So that means there's a negative sign here inside, it becomes positive. So now this is this part. Okay. So we go through all the information for the relative entropy given in this case the output. So now we assume, okay, first we take each sub table at a time. So in terms of outlook, so we have the case of overcast. These are the attributes, these are the properties of the outlook: overcast, rainy, and then sunny. So there are 3 of them. So we have to go through all 3 of them. So let's start with overcast. So in the case of overcast, this is what? the no, four records of yes. So overcast, given overcast, okay, that means that, okay, this is the X, this is the H of, ah, this is the H of the Y X outlook equal to overcast, okay, given, sorry, okay, this is the part of the output yes, given attribute of outlook equal to overcast, okay, and then minus here this will be the outlook and the output of no given X outlook equal to overcast, and it's also negative, okay. So here, so how many are no given overcast? So there's nothing, no in the overcast, so that's 0 log 2 of 0. For the yes, it's all yes, so 4 over 4, 4 over 4 log 2, 4 over 4. So we know that the whole thing becomes 0 because log 2 of 1 is 0. So this is, we don't assign this, we disregard this one, and this one is 0, okay. Now let's go to rainy. So how many are yeses? So in this case, 3 over 5. So there, 3 over 5 log 2, 3 over 5 plus the no, 2 over 5 log 2 over 5. So this is the case for X outlook attribute equal to rainy. Okay, so next, sunny. So in the case of sunny, how many yeses? 2 over 5 log 2 over 5 plus no, 3 over 5 log 2, 3 over 5. So X outlook equals sunny. Okay, now, then we compare everything. We add everything. So now we have, what is this? So this is the X outlook equal to overcast, okay? And this is the X outlook equal to rainy, and this is the X outlook equal to sunny, multiplied by, okay, okay, we know what is this, multiplied by H given Y equal to what? Yes, given X outlook equal to overcast, okay, plus H of Y output given no, Y output is no given outlook equal to overcast, okay. So that's that one, which is this part here, and that's 0, okay. And so this part is again, I hope this is clear. I want to write it down so that it will be clear for everyone, even though it's quite clear already. H of Y, okay, output given yes, sorry, equals yes, given X outlook equals rainy, okay, plus H of Y given, not given, Y equals no, given A X outlook equals rainy. Okay, that is that part. So the same thing here. I just want to write it down so that we can see the relationship. So inside is, again, this one. So that's the part of the rainy part. So here is the sunny part, H of outlook, oh, sorry, output Y equals yes, given the X outlook equal to sunny, okay, and then plus the relative entropy of Y output given Y output, sorry, equals no, given the X outlook equals sunny. Okay, so those are the three summations of the relative entropy, which is taken into this part, that part, and also multiplied into this part. Okay, multiplied by the corresponding, what is this? X attribute of the outlook. Okay, so now here, X attribute of the outlook is what? So this is, okay, X attribute of the outlook is, okay, sorry, outlook of overcast, rain, and sunny. So overcast 1, 2, 3, 4. So this is 4 over 14. So there, that's 4 over 14. Okay, this is the absolute, probability. And then X over, when X outlook is rainy. So 1, 2, 3, 4, 5, 6. That's 6 over 14. Is it correct? 1, 2, 3, 4, oh, 5. 5 only. It's not 6, it's 5. And for sunny, 1, 2, 3, 4, 5. So again, this is 5 over 14. Okay, and then the inside are all these multiplied by 0, multiplied by 0.97, and multiplied by 0.97. Okay, and the result is 0.69 for all the information gain. Okay, for the attribute outlook. You understand? Okay, let's go to the next attribute so we can see it, appreciate it more. Okay, next. Okay, here. So we go to temperature. So again, you have, let's concentrate on the temperature. So in this case here, we take temperature, absolute, there are three cases for the absolute entropy. Okay, you have H of X temperature equal to cool equal to what? And then you have H of attribute temperature equal to hot equals what? And H of X temperature equal to mild equals what? Okay. So, do you understand? Okay, anyway, let me calculate first. So cool, how many? 1, 2, 3, 4. Is that 4? 1, 2, 3, 4. So 4 over 14. Next one, hot. 1, 2. Okay, wait, look. Look here. Okay, hot. 1, 2, 3, 4, 5. Is it 5? You're not looking.
No, it's not.
4.
How many? 4.
It's 4.
Yes.
It's 4. 1, 2, 3, 4. Okay, 4. I thought it's 5. Okay, it's 4. 4 over, or maybe let's call her No, I don't want to say it. I'll be in trouble. 4 over 14. Then mild. 1, 2, 3, 4, 5, 6. 6 over 14. So this everything is 14. Yeah, 6 plus 4, that's 10 plus 14. Okay. So now let's go to, okay, here they're just putting it the whole number, but let me, I want to write the equation so that you will be more understanding. So let's go clear everything first. Okay. Here, okay, here you should know this one already by this time. So let me write out everything so we can see exactly what's going on. Now, so we are taking H of, okay, information gain in terms of X attribute temperature, okay? That is equal to H of the output Y absolute minus H of the Y output given the attribute X of the temperature, okay? So now, what is this H of Y given attribute of X of the temperature? Okay, so that is equal to, okay, let's do one by one. So X of temperature equal to cool, okay, multiplied by the negative, multiplied by the negative probability of the Y output being yes and X temperature being cool. Okay, log 2 of the same thing, probability of Y equals yes, given XT equals cool. Okay, and then minus plus, okay, it's a summation, the same, minus, okay, you go through the different, the one that is no. You go to the different output equal to no, given xt equals cool, log 2 p of y equals no, given xt equals cool. Okay, that is for xt being cool. Now for xt, okay, because these are all summation, yeah, you have to sum. Now for xt equals what is not hot, okay, okay, then multiplied again, the same thing, probability of y being yes, given x temperature being hot, log 2 of y being yes, given x temperature being hot, plus the negative of y being no, okay, because you go through all the possibilities of the output. X temperature, the same thing, it's hot, log 2, this should be 2 here, y being no, given xt being hot, okay, and then plus the third attribute of, I mean the third property or the third variable of the attribute xt now equals mild, okay, minus p again of y being yes, given xt equals mild, and log 2 of y being yes equal to yes, given xt equals mild. Okay, plus the negative of probability of y now becomes no, given xt equals mild, log 2 of y equals no. This is equals, given xt being mild. Okay, here there should be a square bracket there. You understand? So that is the entire equation of this one, of the relative entropy of the output y given your x being temperature, of the attribute temperature. So now let's go. So here you see these are absolute entropies. I want to see this one are absolute, absolute, and absolute. So these are easy. So you count. So we are only talking about the temperature when it is cold. So cool, yeah, one or cold. 1, 2, 3, 4. So that's 4 over 14. We have already enumerated this. And then the hot, 1, 2, 3, 4. So 4 over 14. And the other one, mild, 1, 2, 3, 4, 5, 6. 6 over 14. So we have done that. So now let's go inside. So we go inside and we see that. So now we consider only xt being cool. So here, this is 1, 2, 3, 4. Okay. So in that case, how many are yeses? 1, 2, 3.
3 over 4.
So 3 over 4. 3 over 4. So it's automatic that the other one is a no. So 1/4 is a no without counting.
So,
Yes? Yes.
for the probability at the bottom where xt is equal to mild,
Yes.
you wrote 6 over 16.
6. Yes. You know, Isaac Newton used to be like that when he was getting older. Okay, anyway. There. Everything is 14 because there are 14 entries. Anything else?
No, that's it.
That's it. Okay, now let's go to X being hot. So this one, hot, 2 hots. Where's the other hot? This one.
Hot.
Yes. Okay, now. So how many are yes? 2. So this is 2 over 4. Let's make it green.
1 over 2.
Yeah, 1/2. Let's just say 2 over 4 so that it's clear. You will do it yourself later. And this one is also 2 over 4. You'll just simplify it. Okay. So next, mild. So in the mild, how many miles we have? So there's 1 mild,
6.
2, 3, 4, 5, and 6. Okay, so how many yeses? 1, 2, 3, 4. Correct? 1, and then this is 2, 3, and 4. So that's 4. 4 over, how many are these? 6, yeah?
6.
So 4 over 6, and that means the no is 2 over 6.
2 over 6.
Yeah, there you go. Finish. So you can calculate everything. So here, can somebody just calculate if this is correct? 0.81 for this part, the cool part, this one. Only the one inside. And then this one is a 1. Okay, well, this is 1/2 and 1/2 and equally distributed. That must be 1. And then this one is 0.92. Okay, just to check that here. So you have 4/14 here. So this part here is already 4/14, this one. And then this one is already 4/14 and 6/14 there. All we are trying to do here is calculate that part that's being multiplied, this part that's being multiplied, and this part that's being multiplied. Can somebody check if this is 81? No?
I'm checking.
Okay, who else is checking? So 3/4 times log 2 of 3 divided by 4 plus 1/4 times log 2 of 1/4. Minus 0.81. Yeah, this is correct. And the other one is, okay, I'm checking here so that you can see that's, you can believe that I don't laugh you. So here, 3/4 log 2 multiply inside of log 2 plus 1/4 multiplied by log 2 of 1/4. So that's minus 0.81, but there's a negative in front, so that's 0.81. So next is 4/14. 4/14 multiplied by log 2 of 4/14 plus 4/14. No, 2/4.
Oh,
This is 2/4. 2/4 multiplied by log 2 of 2/4. Okay, times 2. Okay, never mind. 2 divided by 4 times log 2 of 2 divided by 4. Okay, that's -1, so that's 1. So now 4 divided by 6 times log 2 of 4 divided by 6 plus 2 divided by 6 times log 2 of 2 divided by 6 minus 0.9198, so 92. Yeah, that's correct. And so that should be 0.91. Okay, so then we go, understand?
Yeah.
Okay. So now that is that. So given this is your 0.91 is your entropy, relative entropy. So you have to subtract this with the absolute entropy of the output to get your information gain. Okay. 0.91 also. So the information gain. Okay, here 0.94. Okay, now let's subtract this. 0.94 minus 0.91. So this is 0.04 information gain. Okay.
0.03.
Yeah, 0.03. Sorry. Hold on. Let me just remove everything. Okay. Now I think we're confident with the calculation. Let's just check about this one. Okay. So in the previous one, in the outlook, 0.94 minus 0.69. What is this? 0.33. Yeah? No. 14 minus 9, that's 5. Okay? And then 8 minus 6, that's 2. So 0.25. So here the information gain is can somebody write it down? 0.25. So here, 0.94 minus 0.91. So that's 0.03. So here, there. The next one is That is for the temperature. Outlook temperature. Where is humidity? Oh, I don't have the humidity calculation. Okay, but anyway, the humidity calculation will be something 0.215. So, and also the windy, yeah, there. So now, if you calculate everything, the one with the highest information, can you see everything is the same for the first part minus the relative entropy. So all of these will have different relative entropy, and so the highest information gain is the outlook, and so outlook will be the first layer. So now, when you say play tennis, so outlook is the first layer. Okay, so how many? This one is the how you do it. Play tennis. There are 5 yeses, 9 yeses and 5 nos. And so in the outlook overcast, how many yeses you have? 4 yeses and 0 nos. Outlook rainy, 3 and 2. Outlook like this. Yeah. And so now, after this, you are going to continue. To continue to the next branches. You are done with outlook. Yeah. So what happens now? So that means that in this case of the outlook 4 and 0, you take this subtable. The outlook of rainy, you take this subtable, and the outlook of sunny, you take this subtable. Now you consider only this table for this branch. Please pay attention. So for this branch of outlook, sunny, you only take this table. And now you create your next node. You consider what will be your next node based on attribute of temperature, humidity, and wind. You don't consider outlook anymore because it's done. Okay, so for this outlook rainy, you create this, you consider this table alone to check the next node of that. So what about this one? How do we create the next node here? Well, there's one thing that you need to know. In this case, the entropy gain, no matter the information gain, no matter how much you compute here, there'll be nothing because this is already 4 and that's 0. Okay, it's already determined. The information gain, you won't have any. You can compute information gain, but you won't have any. Your information gain will be 0. Okay, so this one, the information gain for everything. Next one, the information gain here will vary because it's still uncertain. This is already certain. If overcast, that guy definitely will play 10. Okay, nothing to move here. Here you move and you consider this. So then we have to do again. Isn't it nice? Yeah. So now you consider rainy. So when you consider rainy, the absolute entropy of the rainy is 3 yeses and 2 nos. So 3/5 log 2, 3/5 plus like that. And 2/5 log 2 of 2/5. This is now your absolute entropy, H of Y. Okay. So now you consider temperature. So now in this case, how many, you only have cool and mild. So in the cool, you have how many yeses? 1 no and 1 yes. So one yes and 1 no. So 2/5, which is the 2/5, which is the no, and 3/5, which is the yes. Okay, you consider the no first, 2/5. So in this case, this part, sorry, I want to make it fast. Okay, the cool, this is the cool part. Okay, and the cool part. Okay, so the cool is 2/5, so 2 divided by 5, that's absolute. So inside the cool, so you have 1 no and 1 yes. So 1/2 log 2 like that. 1/2 log 2, 1/2 plus another 1/2 log 2, 1/2, because 1/2 yes and 1/2 no. So now inside the mild. So in the mild, you have 3/5. So that's correct, 3/5. Now inside the mild, you have how many yes? 2 yeses and 1 no. So 2/3, 2/3 log 2, 2/3 plus 1/3 log 2, 1/3. Okay? So now this one will be your relative, this one will be your relative entropy. So that means H of Y, which is that part, cannot be seen. H of Y, this part, minus this part here. H of Y given X of temperature. Okay, so you'll see the information gain here for X of temperature. So, okay, so this is the case for the rainy. So you solve everything here and see which one has highest information gain. And so if, for example, the highest information gain here is temperature, so the next part will be temperature. Temperature, like that. And temperature. Okay, and then you do the sub, you remove the temperature now, the cool and the mild. So you rearrange. So the next table will be just this table of the yes and this table of the no in case of the cool after the rainy one and the cool and the mild after the rainy one. Okay, so in the mild you have 1 no and 1 yes. So the same thing, you continue. Understand? So I think we're time already. So one thing I want you to remember is that we will finish. Okay, we'll finish the discussion here now. Next meeting we'll do the base rule. And so one thing I want you to remember is that you take the tables whenever you decide already which entropy gain, which information gain has the highest value, and then you branch out to the next nodes given the next tables. So for example, here, let's go through this slide. This is the case of the miles per gallon. Okay, whether good, bad, whether good or bad, given the attributes of cylinder, displacement, horsepower, weight, acceleration, model year, and maker. So the same thing, you have to go through all the attributes. And in this case, it's determined from the root. You have 22 good and 18 out, 22 bad and 18 that's good. And then you create this table of the cylinders. So it is just saying that in this case here, this part here, you don't need to split because this is already determined. When you compute the information gain here, that is 0. This is also no need because it's already determined. This is also no need. So you only do this, and you only, even this one, yeah, you only do this and that one. Okay, so now if you split, so don't split when the matching records are the same output. Okay, this is already determined and that's determined. So we can split here and you split here. This is being split and that is being split. This one, no need to split. Okay, because this one always bad. His one always bad. And this one, no decision, bad or good. Okay. And then here, you don't need to split. You don't need to split. Okay, let's go to the next slide. So here, no need to split. Predict good. Now you split again because this is not yet determined. This one also you split again. Okay. So once you split, you just create the subtables and compute the information gain. So here, finally, no need to split. This one, you still need to split. This one, no need, that one. Until everything is determined. As you can see, the information gain, when you continue, the information gain becomes all 0. So that's the time that you're done. Okay? There's no more to split. So this is the whole tree. Once you see this one, no need to split. So we split only here. So we split here. No need to split. We split here and we split here. So you split the horsepower here. This is split in terms of horsepower. This is split in terms of acceleration. So now determine already this one, you need to split there. This one is 1 and 1. You cannot expand anymore, so you stop. This one is determined. This one is determined. So this one, also 1, 1, you don't need. You cannot expand this one. But anyway, I don't know why they still expand this one. So I think in this case here, no need to, it's not expandable. I mean, you can still expand this, but you run out of attributes already. But here you still have an attribute of model here. That's why this is still expanded, because there are still equal chances of getting good or bad. And so here you take the model and year. So now you can predict good, and this one predict bad, and this one no decision. Any questions? We're done. Okay, I'm running out. We are exceeding the time again. So let me end here. That's it. We're done with decision trees. Very good.
Very good.